Hello everybody and welcome back to our new tutorial, which is going to be mostly devoted to the different types of sockets such as Unix domain sockets and raw sockets and how we can actually create them. So we're going to take a look at that. What we did in the previous video is we took a look at the creation of the UDP client and server, and we also saw how they can interact with each other, what's the differences between the UDP client and the TCP client, as well as what is the difference between the UDP server and the TCP server. And right now we're going to start off with the Unix domain sockets and how we can actually create them. So basically, first of all, open up your idle right here. As usual, what we need to do is we need to import the sockets library, so import socket. And basically the Unix domain sockets are available on the Unix-based systems, of course, which makes sense, and sometimes they are used for fast IPC or pipes between processes. Now the creation is rather similar as the creation of the regular TCP socket or UDP socket that we used before. Just specify sock equals, which is going to be the name of our socket object, socket.socket. And now, instead of specifying socket.af_inet and then comma sock_stream, you should specify socket.af_unix, everything capital, and after that socket.sock_stream. Socket has no attribute af_unix. Let me just see right here, dear socket. Sock.raw, sock_dgram, let me just see, af_inet, okay. Let's just try to find it right here. Okay, so we got the IPX, inet, inet6. Yeah, of course, I'm not really sure why I even try to find this. Let us just go and open up the I'm not really sure why I even try to actually use it on the Windows 10 machine. What you need to do is you would need to have a Unix based machine or a Linux machine, and basically the creation would be the same, just of course in that case the actual creation would work. Right now it won't really work because you're simply using the Python 3 for basically Windows 10, which is the exe version of Python 3, therefore there is not af_unix for the socket creation of the Unix system. So once again, if you wanted to create it, you would simply specify s equals socket.socket if you're running Linux, of course, and then socket.af_unix and then comma socket.sock_stream. You would press your enter and then that would work. The same goes with the actual UDP client, UDP socket. So socket.socket, socket.af_unix, and then comma socket. And you simply just specify sock_dgram, which represents the UDP. Okay. Now the address can simply be a file name in the Unix domain system, so you know that once we actually specify the TCP client in our Windows 10 environment, we would need to specify s.bind, and then in between the double open and double close brackets, what we would specify is the IP address, and then we would specify the port. Now in the Unix based system, address can be simply a file name. So what you would specify right here is, for example, a temporary directory, so s.bind, and you specify /tmp/ and then some directory, doesn't even matter. Basically this is the server binding, and then the client connection, what the client actual program would perform in order to connect. We know that in Windows 10 environment we will need to specify s.connect and then specify the IP address of the actual server as well as the port on which we want to actually connect. Now in the Unix based systems it is simply just connecting to the directory, so all you will need to do is specify in the client side code s.connect, and then in between the brackets you would specify the actual directory to which you want to connect, or basically the file name. As we know, in Unix based systems address can be a file name. Now the rest of the program that you would write in order to perform the server and client connection is rather the same. So rest of the programming interface will be the same as in the Windows 10 environment that we already saw before. Now another thing that you want to actually know about is the raw socket. So let me just delete this. We already imported sockets. Now if you have, for example, root or administrator access, you can gain direct access to the raw network packets. Now what does that mean? Well, first of all, it depends on the system, and the second of all, what the Linux packet sniffing would look like is simply just creating the socket like this. So s equals socket.socket, and then in between the brackets, instead of specifying AF UNIX or AF inet, you would simply specify socket.af_packet. And basically, then you can specify which protocol, for example, socket.sock_dgram, which stands for UDP. Now, of course, because this is on Unix, it will throw us an error right here saying module socket has no attribute AF_packet, because this is only working in the Linux systems, okay? Then right after it, all you will need to do is specify the actual interface which you want to bind to, and also which type of packets you want to sniff. Now what I mean by that is simply, let me just show you in the command prompt, and for those of you who are using Linux, you can simply just type ifconfig in your terminal. So open up your terminal on your Ubuntu machine or any Linux machine that you are using, type ifconfig. Right here I will type ipconfig because right here I'm on Windows 10. And once you type that on Linux, you should see the name of your actual device or the name of your actual networking interface, which can be either ETHO, WLAN, WLO1 or 0, doesn't even matter. It can be different for every system. It is usually ETH0, especially if you're running a virtual machine or something like that. It will be ETH0. And then, in order to sniff the packets on a certain interface, what you would specify is s.bind, and instead of binding the actual directory or the IP address with the port number, what you would bind is the interface with the protocol number. So what I mean by that is simply it will take two arguments. So once again, you will open and close double brackets right here, and what the first argument would be is the name of your interface. So all you would need to do is check the name of the interface on which you are connected to the internet, because make sure if you have multiple interfaces that you choose the one that you have connected internet connection with. How you can check that is simply if you have the IP address asserted to you, that means you're probably connected, therefore you can pick that one, okay? And then in between the double quotes, you will need to specify the name of that interface. So in our case, let's say it is ETH0, because that is the most common one, and the probability of you finding this are greater than any other. Then the second argument would be the protocol number, and what does that mean is basically which type of packets you want to sniff. For example, let's say we want to sniff the IP packets from the IP header. Basically you would specify the IP packet number, which is 0x0888, or pardon me, 800. Then you would specify this, you would press your enter. Now of course this will not work because I don't really have the ETH0 interface and I'm not on the Linux systems. And then all you would need to do in order to receive a packet is simply just specify a while true loop. And in that while true loop you would simply just specify, for example, message and then address. And the reason why we have message address is because notice right here that our socket object has sock_dgram, which is UDP packets and not TCP packets. Therefore, we are not going to store the client's socket object anywhere in our memory. We can simply just connect with the client over address. And then you specify equals s.receive from and specify the amount of bytes, so 4096, let's say. Now you would press your enter and basically this would receive the packets in Linux system. It will get a packet to you. Okay, so simple as that. Basically that is all you want to know about the raw sockets. Of course there are more things about them, but for now on this would be more than enough, as this is the beginner's course. Now another thing that you want to take a look at, but first of all let me just restart this because we got too many errors since we are not running on the Ubuntu machine. Now also one more thing that you want to know is that servers usually handle multiple clients. So what we did by now is we actually took an example of creating the TCP and UDP client and server, but we only accepted one connection. And you should know that these servers handle multiple connections most of the time. So in order to create something like that, you will need to specify that each client gets its own socket on server. Now why is that? Well, simply, let's say you're creating a TCP connection, which you most likely are, because there is no really point creating UDP connection with the multiple clients, and mostly because it is connectionless, and you really need to specify the address in order to communicate with a specific client. In the TCP connection, what you need to do is simply just create a socket object and then accept the connection, which will store the socket object of the client into the first variable. So if you remember, we would specify something like this, s equals socket.socket, and in between the brackets socket.af_inet in order to create the IPv4 connection, and then socket.sock_stream. Then you would press your enter, and then while true loop can accept the actual connection. So CA equals s.accept, and therefore you would right now accept the connections. Okay. Now it says right here invalid argument is supplied because we didn't really bind or listen or didn't perform any other connection, or pardon me, we didn't perform any other function that we need to. For now on, I just want to show you how you accept connections in this TCP connection. So right here, this variable C would store the client socket object. Okay. So now another thing that you should know in order to manage multiple clients is that the server must always be ready to accept new connections. So therefore, what we're going to do in the next tutorial is we are going to introduce ourselves with the term called threading. So we're going to introduce ourselves with the threading in Python 3. Now, why we need to actually learn that? Well, simply because of this statement that the server must always be ready to accept new connections. You know that this accept function hangs until a new connection is connected to you. Now you don't want your program to always pause while waiting the connections. You want your program to continue executing at the same time as it is accepting new connections. And in order to perform something like that, you need to make a threaded server. Now also, the server must allow each client to operate independently. Each may be performing different tasks on the server, therefore they need to perform independently. Okay, and what we will do is we will basically code a brief outline for this solution, but before we actually do that, what we want to do is we want to introduce ourselves with threading, and then after we learn threading, we will go on into the threaded server. Okay, so that would be about it for this tutorial. I hope you enjoyed it, and I hope I will see you in the next one. Bye!